go live. And all
I
right,
booked my
we're
hotel
live.
for Great Lakes Stargaze.
Cool. That's the week before Astronomy at the Beach, right? Is it the
Yeah, September 9th, I think.
9th? That's 2 weeks before.
Yeah.
Yeah, I got a RV spot reserved up there for the week.
Yeah.
Yeah, that might be an overnight drive 'cause it's about 3 hours from where I'm at. 3 hours has become a standard easy trip for me now. So
I was gonna say, Adrian, you're all over the map.
chase the skies wherever the
Yeah.
wherever the skies are dark. That's where I try and go.
I remember when I was young.
Nobody else does.
Well, I remember that I was young. I don't remember anything about it, but I did.
No,
That Friday night, Adrian, when the smoke cleared out,
yeah.
it was good at Lake Hudson that night too.
Yeah, I bet you had you had a pretty bright sky. Well, a lot of stars. I've seen it like that before, and it's surprising sometimes.
Yeah, the sky didn't clear till like 11:30. I was really worried we'd go home with nothing but
As
clouds
soon as
moved
it
out,
cleared,
and it cleared nicely. It
yeah,
was dry air too.
yeah, just have to wait those out. I had it clear like that, and then I decided to pull a camera out to get some imaging done, and the clouds came and made sure I couldn't do it. Then I gave up. The clouds were slowly receding, so I said I quit. And then the rest of the clouds disappeared at that point, and it was back to being dead clear. I decided I wasn't going to pull my camera out because clouds will just show up if I do that. So I just left it as is.
Inside a big loaf of bread or something, so the clouds don't see it.
I'll try that next time.
You know what? You want to see what the smoke map looks like for tomorrow night at 10 o'clock because it's supposed to clear here.
Go ahead and share.
That smoke map does not look all that great, though. There you go.
Well, it was terrible the first time. We were in the red. We're
Right
surrounded
here.
by smoke everywhere.
Yeah, but if you back it up just a few hours, to today or 2 o'clock in the afternoon, it's actually, the smoke is actually clearing to some degree. But 8 o'clock tomorrow.
Supposed to knock any of it out of the atmosphere?
Pardon me?
Is the precipitation going to knock any of it out of the atmosphere?
That depends.
I think the smoke might be above the rain.
I think it is.
Yeah, that's what I meant. Kind of depends on how high the smoke pattern is. But this is relatively clear compared to everything around us.
You can see quite a bit of haze between the cumulus clouds yesterday. It's remarkably cloudy or hazy. Mm-hmm. What would have been blue sky was actually quite hazy.
This is 5 o'clock this evening. So but this is terrible stuff out here.
Yeah, I was asking if purple, is purple the worst and blacks?
Yeah, purple's the worst. It's the densest smoke out here.
Yeah, the state of Nebraska has a month for that stuff to clear out of there, or else their star party is going to be ruined. Those dark skies that they are trying to get a dark sky designation, and I think they'll get it, but they're also they're in danger of being smoked out of that that star party. It's the beginning of August.
Yep. I was thinking of going out there too.
Yeah,
we noticed it at Fish Lake that last weekend. The transparency should have been much better, but it was definitely hazed. Which, by the way, my new CGXL mount with that 14-inch SCT worked beautifully.
Well, let's hope it's dead. It's clear when we get the Okie-Tex. We'll get a chance to see what that thing can do. We're gonna miss Smurfette though, Doug. I was looking forward to that. I was gonna borrow your camera if mine went out of commission to shoot some things. I'm coming, Nike. I'm coming with
No,
all three of
Smurfette
them.
wouldn't have been coming anyway. It would have been the big one.
Papa Smurf. Yeah.
No, that's
Nathan's probably bringing that.
that's Nathan's. Yeah, I think he said he was going to.
He's got a new mirror in it, so.
Yeah.
Speaking of
That
mirrors,
should be
I
fun.
sent out our Parks 12.5-inch to that Spectrum Coatings down in Florida, Deltona, Florida. Expecting it back in a week or so, maybe 2.
Norb, did you just say oh crap. What you got? Parks.
A Parks 12
That's
and a
an
half.
old brand. That's an
Yeah.
old brand. You just don't see
Yep,
much
it was a
anymore.
beautiful scope. I paid $5,000 for it using university money in 1988.
Yeah.
It's a beast of a scope, but the mirror needed coating. Kevin Daney had his 13.1-inch coated at Spectrum. They did a nice job.
Yeah, I've had all mine done recently there.
With success, I take it.
Oh yeah.
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 Okay.
Yeah, no, they still have a good reputation.
Okay.
Yeah.
Yeah, we haven't gotten our mirror back yet, so I'm just
Yeah, they're
hoping that they'll,
dumping-
because the optics on that Parks mirror are excellent.
Yeah. Yeah, their turnaround can be a little slow, but they do a good job.
Okay, thanks.
Well, I've still got a minute and a half to ask. Can I get a vice president to volunteer to take minutes? Now, you know you can't look like that, Joy, and not stick yourself for it. Thank you, appreciate it.
Yeah, I would stick up for Joy, but I'm
Well, you
trying to
got enough to
stream.
do.
Yeah, I got
Yeah.
2 computers and a
Exactly.
whole lot of mess. I'm following along. The stream is going. So I just got to keep the audio down on the YouTube stream so I can follow along and watch the chat there. Yeah, I got devices and I might be the backup presentation person, so this is going to be fun.
And with that, if you're ready, I'll go ahead and get started.
Yep, we're ready. We're
Okay.
live and it's working.
Yep.
Let's do
Okay,
it.
so welcome everybody to the July meeting of the University Lowbrow Astronomers. Just as a reminder, we are recording on YouTube, so we got to be on our best behavior. So as usual, we are going to have our guest speaker first, and then we'll have officer reports after we take questions. And so with that, we're really very honored to have a very prominent speaker tonight, that being Dr. Thomas H. Zurbuchen. See, I knew I was going to mess it up when it came to it. But fortunately, Thomas said we can call him Dr. Z or even Thomas. So, but Thomas is NASA's Associate Administrator of Science. And in that role, he's responsible for NASA's science program, including Earth science, heliophysics, planetary science, and astrophysics, with a total budget of approximately $7 billion a year, which is a little bigger than our treasury. With this program and a diverse set of leaders, he is helping answer some of humanity's biggest questions. Where did we come from? Are we alone? And how does the universe work? Growing up in Switzerland, Thomas was a keen observer of the natural world from an early age and received a public education with master's and doctorate of physics degrees from the University of Bern. His science and leadership career focused on solar, heliospheric, and planetary instrumentation and data analysis as a professor at the University of Michigan in Ann Arbor, where he taught in space science, aerospace engineering, and innovation-focused classes. He led several University of Michigan innovation initiatives in both education and research, one of which led to the top-ranked undergraduate entrepreneurship program nationally. Dr. Z joined NASA in 2016. His honors include induction as a member of the International Academy of Astronautics, a NASA Outstanding Leadership Medal, in the 2018 Heinrich Greenocker Prize from the University of Bern. Dr. Z engages people worldwide with NASA's work in the inspiration of science. He can be found, by the way, on Twitter at Dr._Thomas Z. Tonight, we're honored to have Thomas with us for a talk titled Together We Explore. So with that, let's please give him a warm welcome. Take it away, Tom.
Well, thanks so much. Andrew, why don't you fire up the slides just so we have something to look at. Look, I'm really honored to be part of your evening today. I recognize that all of you chose to not go to the art fair, and I know that's a sacrifice. Well, it may not be, I don't know. I lived in Ann Arbor for over 20 years, and there are years where I really wanted to go, and there are really years where I didn't want to go. So I want to, thank you also for, of course, being advocates for observing the sky, a sky that to so many of us means more than just dots up there, and kind of says a lot about who we are and where we are in the universe. I don't know how you feel, but every time I look at the sky, it really feels like it's more important than I am. And that is a really good feeling, I think many of us benefit from as we go forward. So you already introduced me. So what I'd like to do is just kick it off and go to the next slide, Andrew. I want to just tell you that Andrew Scher is one of my good staff members who is here and helped me with this presentation. This, by the way, is a view from just where I grew up the hill. And you see, of course, as this camera pulls out, you see the fog in the bottom, which makes you believe it's great to be on top of the hill. You also see the mountains that are there, mountains, some of which I've climbed. Some of them are way harder than I can climb. Some of them in the left and the back there are really high, kind of tough mountains that take a lot of technical skills that I don't have. But kind of for me, kind of achieving, and especially after this year we just had, over a year, dominated by COVID. Basically, there's a number of lessons that I learned, and so often I remind myself of the experience that I have climbing mountains. And so what I'm going to do is just really use that experience to kind of organize some of the lessons learned here as I talk, tell you some stories of our portfolio. So that's what I'd like to do. With that, give me the next slide, Andrew. And kind of it's really about 5 stories, 4 substantial ones, and the last one much more of a conclusion. And they all relate to the fact that the way we do these things at NASA, the way we do science is together. The entity of relevance for an important mission is not an individual. No matter where they are in the organization, it's a team. And so for me, when we do these amazing things, either looking up from Earth or down at Earth, we explore together. There's a number of lessons, as I said, that I became aware of very deeply as I look at last year. And that is, as we explore, we are inspired to think big, equip ourselves for the challenges ahead, and then build the right team, persevere, and recognize from that we can face challenges that we never thought are possible for us to achieve. Those are all lessons, by the way, again, that I found as I climbed up mountains. Kind of aspiring to go up on a mountain is really important. Being ready for that hike, building the right crew to get there. No matter what you do, the kind of things that you want to work on are the ones that get hard somewhere on the way. And perseverance is part of that. And of course, that once you're up a mountain, you see other mountains that you can get to that you would have never guessed of. So that's really what I'm going to talk to you about and launch into it. The next slide is about the first story here, which is together we're inspired to think big. And it's really about, again, kind of starting out. It's about setting vision. It's about moving forward along that mission. So for that story, what I want to focus on is something that you're really aware of, deeply aware of, and it's of course related to our night sky very much. And why don't you take the next slide? Yeah, here we go. It's basically all about galaxies. And of course, the first galaxy that we're aware of when we look at night, and especially if it's dark enough, is our own galaxy. And it's our own Milky Way that is there. And there's that brighter stripe across it. I still remember it well from my parents' home up in the Swiss mountains where there's no industry. And so kind of it's in the middle of valleys. So you see a lot of that. You also see some things that are moving, and you see that kind of in that picture that is taken here behind the tree there, you see that stripe. But of course, that's the space station, which remind us, well, you wouldn't have guessed it's a space station, could be some other thing that's also flying. But it reminds us that, of course, we have presence in space for over 20 years. Kind of Americans and international partners have been in space without break. Now, what I want to focus on, of course, is the Hubble Space Telescope. And since I'm talking about Hubble, I want to just tell you what happened today and yesterday. For over a month, Hubble was basically in a standby mode. And the issue it's actually a really kind of a weird thing. We actually had all the instruments were there waiting to take data, and the spacecraft were flying happily. But the computer that was there to collect data, but also protect the instruments, basically could not get started. Initially, we thought it was a corrupted memory. That happens from time to time as you're in space and you pick up some of the radiation that's up there that, of course, we're shielded for because of both the magnetic field, but more importantly, the atmosphere that is shielding us from it and our electronics. Well, we went around and round and round until we realized it's not the electronics. The storage. We had switched to a number of redundant things, and kind of after one attempt that for a half an hour got us back beyond that issue, basically it had kicked out into that standby mode of those computers, and they couldn't get around. And what we had to do, and I remember this week at Thursday, at 5 o'clock, I was in Los Angeles. I heard a presentation about what we're going to try to attempt today, and yesterday actually was Wednesday morning at 5 o'clock. I heard that what we were trying to do, of course, is to switch from the side of where the power is there to another side of the spacecraft. The other side, you say, well, what's hard about this? Just switch. Well, I have to tell you, I worked on a spacecraft when I was at Michigan, and it's called the Advanced Composition Explorer. And when we switched the side, we lost the spacecraft. And we needed to get it back because the star tracker no longer connected to the other computer. Well, what made this more exciting is that actually the spacecraft the side that we switched to, we had never operated in space. So after the last servicing mission, we had never switched to that other side. So needless to say, all of us were on our toes tremendously. And of course, we worried about losing the spacecraft. I want to tell you that as of today, of all the instruments, 2 are already back on, fully there. The third one is going through an operational mode. We believe tomorrow we can go back to science operation. And I want to tell you that if everything goes exactly like I hoped, on Monday, I'm going to show you on my Twitter account and all over the news, we're going to show you the first picture after this hiatus. This is the longest hiatus since the 90s. And it reminds us, of course, that this machine is older, but it also fills us with tremendous gratitude because this machine, this spacecraft, has taught us more about the universe than any one spacecraft, I would argue, that we've ever built. It has the publication record that it has. It's well over 850 publications each year still, and makes it the most productive spacecraft still of any and all spacecraft in the science program that we have at NASA. I want to talk to you about, I just thought you would be interested in this. So there's a little bit of anecdote behind the scenes that is, I thought you would like to know. But what I actually want to talk to you about is the person behind Hubble. And it's a person you may or may not have heard about, and that is on the next slide, which is a woman called Dr. Nancy Grace Roman. We refer to her within NASA as the mother of Hubble. Basically, she was one of the first graduates with a doctorate. She got her doctorate at the University of Chicago, and actually had a really tough time. Pretty much every step along the way, people told her she should not study. People would bring up that women should have other functions, of course, that are more appropriate for women. And of course, she persevered. She became, as NASA was being put together, she became the first female highest level executive in NASA as she built the spaceborne astrophysics program, which was a great idea, but nobody really knew how to do it. She, together with others like Spitzer, came up with the idea, of course, and the recognition that most light that stars emit does not come on Earth. It's only a certain set of windows that come, and the rest doesn't, whether it's X-rays, ultraviolet, some of the IR, and especially, as I said, far infrared. We could not see that. Nancy Grace Roman persevered and basically actually went and was an important part of selling Hubble to the congressional and the agency stakeholders. And frankly, for many, she was one of those, I would say, hidden figures, as you know, I'm referring to that movie that is one of my dearest, about really the stories of so many of the people that we have not heard about. So I hope you remember, as you think about Hubble, you think about Nancy Grace Roman, and especially because, as you see on the next slide, the kind of images that are there from Hubble, of course, have shaped how we look at the universe. So the scale of our own galaxy, of course, is enormous. With 100,000 light years going from one to the other side or more in many of these galaxies, or 6 trillion miles going across this galaxy, and as well as others are, of course, full of stars. And as we learned, when you look at all of these stars and kind of celestial objects, you realize that basically every one of those stars, we don't only know that from our own galaxy, but on the average, every one of those stars, of course, has a planet, at least one that is there. And of course, types of planets, many of which we don't have any of in our solar system. So that's what I think about when I see these amazing pictures, again, enabled in this case by Hubble. The probably most prevalent picture, of course, is the one that is the next picture, which is the ultra deep field, which of course is collected looking at very dark part of the sky over 3 months and 23 days. And kind of the way I explain it to amateurs, and I've done it many times, is you take a penny and you look at, what is on there, George Washington, right? If you look at the eye of George Washington, you stretch out your arm, roughly speaking, for normal humans, I mean, you may be, Phelps, who has enormously long arms, or somebody who has enormously short ones, but for most humans, the angle kind of from your eye to that eye of George Washington, that opening of that is roughly what you're looking at in the kind of aperture from Hubble, from that is shown here. And of course, what is shown instead of total darkness, which is what would we see with normal telescopes from the ground and so forth, you see 10,000 galaxies in that area. And of course, that just tells you how much bigger the universe is and how much richer the universe is. Many of these are galaxies of different ages. And of course, the light that came here, in some cases, has been on the way billions of years. The light that is collected in this case by Hubble. And so for me, that's an iconic picture that Hubble, of course, did. Now, the next slide gives you kind of an overview of some of the accomplishments, and just 10 terabytes of data with an archive now over 150 terabytes. Basically, it's all the way to 13.4 billion. And that last picture people argue about, if you look at the publications, how far back in time and away from the Earth we're looking at. And then, of course, 1.5 million observations since then. And as I said, tremendous publication right now, but accumulated 18,000 papers or so with Hubble data. And just think back now of that Nancy Grace Roman, kind of imagining that. thinking big and then seeing what happened. It's just one of those things. She passed away in 2017, I believe, and saw, of course, the enormous success that Hubble was there and generated. And I'm so relieved tonight, believing that we have another few years of Hubble ahead of us. Of course, we don't know how long, because it is an aging machine as we go forward. Therefore, it's important to look at new machines, and I want to tell you about one of them that is there, and that's the next slide, Andrew, that is focused on making Hubble times several hundred. And what it is actually, it's the first telescope named after a woman. It's after Roman, Nancy Grace Roman Space Telescope. I was really excited to name it after her. And it's a telescope that basically has the same primary mirror, 2.5 meters of Hubble. And it's a much faster telescope. And basically, you see the ultra deep field, the kind of very thin, kind of bluish, a square in there. That's what I just showed you. And you see that at an instant, Roman can see everything that's covered up by these tiles that are, all of them are individual CCDs, very high, much more sensitive to the IR than Hubble. And that's what we're going to do there. Basically in a single shot into the sky, we'll get a ton more data. I mean, we're going to overtake Hubble really quickly with this one because of its speed. Of course, the reason we're doing this is because the questions we're after are very different. Instead of looking at individual objects, we're trying to look at the sky overall, because what we're trying to understand is the prevalence, the physics of dark matter and dark energy, for which you need the full distribution of matter and deep. That's why we need to go to the IR. The Hubble being very much sensitive also to UV, we're focused on depth, going to IR for this particular one. And that's what we're going to do again with Roman. The next slide, basically having her name, Nancy Grace Roman's name, up in the sky. You see there's some, similarities. Of course, we're going to go to L2, which is, a million miles kind of in the way behind the Earth, so to say, if you look from the side of the sun. And so basically the Lagrangian point back there. And it's going to be, of course, it's shielding itself from any glare. That's what that shield is about. You see the solar panels that's sitting on top. So there's some similarity to Hubble, of course. By the way, this is imminently serviceable. We organized the whole telescope for it to be serviced back there. So hopefully by that time, we know how to serve it at L2. It's, of course, a lot farther to go to L2 than the moon. So we're going to try to learn how to do that and equip our astronauts to do that when the time comes. So that's what we're building with her name on it. In parallel to that, the next slide is something actually I just want to tell you what I also did this week. I want to tell you, of course, this is a picture that is already a few months old. It's the last time the James Webb Space Telescope was deployed. I have to tell you, I have a lot of scars on my back. I only was at NASA for 5 years, but this is such a hard telescope to build. You see 6.5 meter primary. It's all adjustable. Each one of these mirrors has something like 12 adjusting, dials. You can kind of either move the orientation, but also change the shape ever so slightly. And of course, it is protected and kind of is cooled down to very low temperatures because of these 5 sun shields that are, each one of them has the area of a tennis court. And they're all deployed in space, just like a transformer. You've seen the movie, right? It's coming up and unfurling. I want to tell you that I went to Los Angeles this week because I wanted to see it one more time. Show me the next slide, Andrew. You see kind of people working on this. They're up on these cherry pickers and ladders and cranes, and it's really crazy. But I want to tell you what I went and saw this week is the telescope before it's going into the shipping container. And so our full expectation is to get this launched later this year, very likely somewhere in November. That's when it's going to be launched. And just want to tell you, it's absolutely exciting to see that. Again, it's almost too hard for us to do this. It's just at the hairy edge of what's possible. Frankly, we struggle tremendously as a team. There's many things we learned that we're better off for it. We also made some mistakes that frankly are most unexcusable. But the point is that we're getting there, and the science community overall is absolutely amazed and excited about it, especially as they're getting ready to do the first year of science. All the proposals are selected, and we're ready to go. So now we just need it on orbit and deployed. So that's what's going to have to happen in the second half of this year and the first month probably next year, because remember, it takes 120 days to make this thing go to temperature and deploy. So it's a really, really a long and involved duration. So that's what we're doing there. Just really exciting about it. The next slide. What I'm going to do is just quickly, since you're all astronomers, I'm just going to quickly stop here and see whether there's any questions about what I talked about, because this is really fully astronomy and I wanted to put it in. And I have absolutely no aspiration of going through every one of these stories. I just want to make sure that if you wanted to ask questions, just fire away right now. Turn on the camera and just kind of let's stick to this, right? Kind of the telescopes that we're building. Just focus on these. If you want to ask questions, do so.
Well, I'll just wanted to say bravo, I guess, on the work in getting Hubble back up and online. It sounds like the problem was found out, and the your explanation of it, I caught most of it, but just curious, the final piece that made the puzzle come together. How did you all finally figure out where to look to start getting those systems back online?
Yeah, so we thought it's as I said, it's a corrupted memory, and that was not the case, because the reason for that, we switched to other memory and the memory came up just fine and the same thing kicked out. And then one of the scientists remembered that with an Earth science telescope called Terra, we had a problem because of a voltage regulator. So basically what happened, the voltage that was holding that memory, kind of when it gets radiation over time, it can sag ever so slightly, right? Kind of the analog circuit that makes the voltage kind of regulated can sag ever so slightly, and it can get below a hardwired threshold. So basically the software, the hardware is trying to protect itself. And so basically that was the hypothesis. We only proved that yesterday evening at around 10 o'clock, because we had to, if that's the hypothesis, you can switch to the other side and the regulator presumably has not aged at the same level. And then you turn it on and it can hold the voltage. And so that really is what happened. So it's an analog electronics and aging electronics problem that got us, that we identified. And that the team basically, and it's actually super hard to find, frankly, what they did is kind of a funny story. Some of you, may relate to that. They brought in Hubble alums, as they call them. So some of them, in their vacation resorts in Florida or wherever they are spending their retirement, it's like, hey, do you remember what you built here? So of course we have kind of what we call a flat set. So we have a full Hubble electronics that we can use to kind of try things. But frankly, the electronics to that full extent, we don't have a full telescope. So it's really hard to find it. But kind of after we poked at it, just because of the process of elimination, we basically identified it's that regulator. And as I said, ultimately it was proven correct. But that's, Adrian, that's what the answer is. I hope that explains it a little bit better.
No, it's in any problem solving, I always find that needle in the haystack. You find that one little needle that was the problem, and everything else just begins to work after that. Everything just sort of cascades back into place, and that you're tempted to believe it's a major problem, and then ultimately something small um, brings everything out back to life. I've noticed that about problem solving, and it looks like it was in this case a much harder thing to find, but brought everything back. Everything came back once you found it. So bravo to the team. Looking
I'm
forward.
excited for them too.
Yep.
Any other questions about this? Just the telescopes here. By the way, the one thing I want to tell you is that besides the launch of Webb, we also have a launch of X-ray telescope, which is a polarimeter. So it's basically an X-ray spacecraft that for the first time can measure magnetic field effects on X-rays, which will be really important next to active galactic nuclei as well as other objects in X-rays. That's a small explorer that we're going to put up also later this year. So that's it's currently in test in Colorado, getting ready for launch. This one, of course, Webb will launch in French Guiana, which is due south from where I'm sitting. Any other question anybody wants to ask about telescopes before I move on? All right, Andrew, here's what I'm suggesting. Go to slide 24. So what I'm doing is I'm cutting over the Earth science observations, not because I don't think they're important, but I'm trying to match what I think is most of interest to you. The Earth science observations, we're uploading, actually, Andrew is going to put, if he hasn't done it already, in the chat, the slides. So you can go look at them. There are Earth science observations that are just absolutely stunning. All the tools that we have available for our telescopes, we're using also at Earth science and then some. And the value, of course, of these data are incredibly important. So kind of look at them yourself, especially as we look at the droughts in the West, the floods in Europe, and so many of the other challenges that relate to the sea level as it's going up and other issues. Our space assets are just absolutely critical, and they equip us to deal with the situation at hand, which is the point that this was what I'm going to make. What I'm going to do here now is focus on building the right team. And really what I want to talk to you about is a specific mission that I spent a lot of time on last year in the middle of COVID. And Andrew, why don't you switch to the next one? And I want to kind of start out with Sierra Gonzalez. I'm just going to talk to you about her. Frankly, I met Sierra because I was standing there behind her. And just like many times in my life here, in my job, kind of trying to bite off my nails because I'm nervous, right? It's one of those days where we walk in there with two speeches, right? Kind of the one that you want to give and the one that you never want to give, but you have to do both because of the fact that it's so critical. And Sierra Gonzalez sat there. She's a system engineer who worked with the OSIRIS-REx spacecraft. It's a spacecraft that actually was launched in 2016. Before I even joined NASA, I was still at Michigan. And basically, of course, Sierra actually also at that point was still in Reno. She grew up in Reno in a family with musicians. And she was the first engineer. We talked about jokingly how the parents noticed that whenever they bought something like IKEA or something that had to be assembled, that she would take out the tool set and put it together. And she's like, well, you're a different species than all of us. Artists, right? Musicians. And she became an engineer and kind of got motivated about engineering because she met in one of these career days a system engineer. And she went to Lockheed Martin, and there she was, a system engineer, and frankly was the real-time operator of a spacecraft. This OSIRIS-REx spacecraft has achieved a really important milestone. So let's talk about that. The next slide talks to you about this spacecraft. So first of all, the spacecraft was next to asteroid called Bennu. So Bennu is a special place because if you looked at the asteroids, of all asteroids that we know today that have the largest risk of hitting the Earth, this is one of the top 5. And it's basically crossing the Earth's orbit. By the way, the likelihood that it's hitting the Earth in the next 100 years is less than 2%. So don't worry about it too much, right? But kind of the point is, it's still very close by. So of course, what this mission was supposed to do is go to this asteroid and do something pioneering we hadn't done, which is to bring back samples from this. Well, the way the spacecraft was built is that the way that the sample was supposed to be collected is basically, if you want, kind of closely approximated to a beach, like kind of go to something that looks sandy, stick your kind of nose into it and do the reverse of just a vacuum cleaner, right? Kind of a fancy version of, well, $1 million version of a vacuum cleaner, because it's not really a vacuum cleaner. But anyway, so do that and then fly away with that and bring it back to Earth. Well, what happened as the spacecraft flew up there and went into orbit, frankly, there was no beach anywhere. Frankly, it was what geologists call a saturated surface. So think of it as like taking rocks and throwing it on a stack, just rocks. Everybody pick up a rock and throw it there. That's what, at the end, what you get there, if it's self-gravitating, is a saturated rocky body. So that's what you're looking at. And frankly, we could barely find a place to go pick up rocks. Frankly, you're looking head on, right in the middle there in the right of the picture, you're looking head on at a place called Nightingale Crater, which is just there, just in the middle, slight indentation. That is one of the most promising ones. But even there, the issue was that actually what we had intended to do, which is using a LiDAR, to go pick up this thing, is actually not working. What we needed to do is totally reprogram the spacecraft to a totally different analysis, a totally different approach technique, and basically use the same technology as the automotive friends are using in Detroit for autonomous driving, which is one of kind of visual guidance and frankly, kind of identifying obstacles and staying away from them as you drive down the street, right? So that's what we had to do. And in the middle of that is that system engineer, Sierra, who now ran the team to basically go and pick that up as I stood behind her. So there we go. The next slide shows you that moment, standing there. Basically, the team is there. And in parallel, what happened is that arm, the spacecraft is sticking out the arm, and with a speed of something like just inches per second is driving into it. By the way, the arm went in something like 2 feet into the rocky surface. Everything fell apart like in a dusty surface. And you see everybody armed. We see Sierra there in the back. We're all cheering as we learned, as the data came back from space, that in fact, what had happened is exactly what we were hoping, which is that we had picked that up. By the way, we saw a lot of dust in the target cameras as we flew away, and the dust, of course, was flying with us. Remember, it's in vacuum, and that this is a very low gravity, this body, and basically flying in vacuum as we were backing away from it. Now, we were all cheering. I remember I was there. We had, we were all with masks, if you look correctly, we're all with masks, and we're excited. And I got back on the plane, and what we were going to do is look at the detector head and see whether there's anything in it. And then what we're going to do is measure it. So the question is, how do you measure how much mass you picked up? Well, remember the ice skater on the rink, right? We already had spun the spacecraft. We knew how much it's spun, how what its inertia is to spinning, right? And so basically what we're going to do is do the same. And because of the fact that the arm that we're going to strike out has mass in it, it has more inertia to spinning, right? So you can actually measure from the moment of inertia how much mass you picked up, right? That's what we were going to do. All that happened is not that. I got back on a plane and I landed and my phone rang, and Andrew, show me the next one. What the leadership team sent me a picture with this in it, and he said, "Look, good news. Do you see there? There's the diaphragm in the middle of this ring, and see, it's all dark. It used to be transparent before we hit the body. So behind it is all this dusty, dark material that is there. The bad news is, do you see the indentation there at 9 o'clock? If this was a clock, at 9 o'clock, there's an indentation. And of course, that indentation says that there's rock stuck. We actually looked at it, rock stuck, and kept it open. So all the plans that we had made kind of spinning and so forth were exactly the wrong plans, because frankly, we have all the material, but if we spin it, we're driving the material out. You see, there's already material coming out. We knew that there's kind of in these pictures, something like 50 grams had already come out of this kind of hole as this, this dust was without gravity, was kind of milling around and seeking the way out, right? So what we had to do is, again, work as a team, just like whether it's Sierra or everybody else, but work as a team in ways that we had never intended, and actually work as a team to, as fast as possible, stow away this thing. So it's my decision when we're ready to stow. I basically made on the spot the decision to stow. And basically what we had to do is, Andrew, show the next one, is within 24 hours, take that front, you see that thing that looks like a little cylinder, that's that head, put it in with the arm and put it right in top of this kind of, what is this brownish kind of piece of a cone. What that is, of course, is the capsule that's going to be tossed into Utah in 23. That what's opening the lid on top, by the way, is the heat shield that will protect the shield, the sample. What's below it, in that brownish kind of part, of course, is a parachute that will slow it down so it hits the surface of Utah the right away. We had one attempt and immediately worked. The team came together literally, kind of in ways that we had never intended. And I was just so proud of this team kind of coming together again during all of COVID, during all of this. Now, they couldn't solve the problem themselves. And Andrew, the next one, please. So what we had to do, because of the fact that we're doing this out there with an asteroid, we needed to totally change our entire system of how we get data back from space. So 16 missions gave up Deep Space Network time to assist OSIRIS-REx for that sample storage. All eyes were, if you want, on OSIRIS-REx to do that. And kind of for us, that is what we're doing, kind of setting that example of teamwork, but also, again, all the other missions being an important part of it. Needless to say, we do exactly the same for them if they're in trouble. And that's what we did. Now, we put it away. Everybody is celebrating. And we flew by it one more time just a few months ago. And I want to show you that picture. I just wanted to, before I go there, just tell you how excited I am about the team. And I want you to look at the team. So often this is a NASA team, kind of the type that do these amazing things. Sierra sitting in front there. But of course, I could talk about every one of them, but I wanted to talk about Sierra just because I want to tell you that in so many of the NASA teams of the far past, right, so many of these amazing scientists and engineers would not have been there. So I'm just so proud of them. Show me the next ones, Andrew. Anyway, so what you see here is the GIF, which is the before and after. So I wanted you to look at this. So this crater there, again, the spacecraft came in and basically took, that if you look at this crater like a ring, it took something like 20% or so of that kind of to fly down there. So the crater is not very huge, is my point. By the way, the one rock, which is at 4 o'clock, do you see that kind of big rock? We call that Mount Doom. So that is kind of a building. If you looked at it, it's a building with 4 stories. So it's a huge, so you're flying down the street, so to say, with that spacecraft, and you're hitting the surface. And what you've seen now in the meantime is that some rocks were flying from A to B, but also that sample head went way down and actually collected the sample and flew away and left a mark that is now visible for anybody who flies by. Like we did here. We're now on the way home, as I said, and in 23 we'll get it back. And when we get the samples back in the best labs that are available to humanity to look at the history of the solar system and the pieces that made the solar system, the inner solar system, we'll never forget, of course, the team that got us there in the time of need. Not only the ones that had the ingenuity of figuring out what it takes to do this, but also the ones that actually actually picked up that sample and rescued it from our plans, so to say, that we had initially thought about. So I thought this was just a cool story, one that I learned, as I said, during this COVID time. Teams really, really, really matter when it comes to what we're doing. The next slide is the goodbye picture. As we flew away, that's the last picture. And as I said, kind of in 23, and we already know which exact date, September 24th. You're going to see in the news how it's going to go down into Utah, and that capsule. Well, of course, that being a lab, I will not be surprised if some of these samples also go to the University of Michigan or other universities that are nearby you. All right, so let's take the next one. So together we persevere. And of course, you can already anticipate where I'm going with this one, because this is one of those names that is quite popular now, a name, Perseverance, that we of course thought about a lot during the last year. It's a name also that, of course, is the name of a rover that is on top of Mars right now. So let me tell you that story. And I want to start with the next slide with an event that happened on March 5th, 2020. Remember, of course, when everything changed was around March 15th. And I remember I was doing an event in I think in Michigan, you would call it a middle school. And basically with Alex Matter, who was there. And we were telling him with a TV audience, a national TV audience, that we had selected his submission among tens of thousands of submissions to as the name for the new rover we had initially referred to as Mars 2020, referring, of course, to the time we were launching. Lori Glaze, who is the planetary science director, stands next to me as I shake his hand, and we were really excited to do that. By the way, just before I even got home, I got the first phone calls that told me how uninspiring that name was. Frankly, they said, why wouldn't you do something like curiosity and spirit, opportunity, like hope and vision and things like that, that are what they said positive values, as opposed to perseverance. That seemed like something negative to them. In fact, one of the leaders of the organizations that built Perseverance called me and said, well, I'm really worried because this may indicate that we struggle building this spacecraft. I said, didn't you? Because of course I knew how hard it was even before COVID to do it, and frankly, so nonetheless, there was a lot of criticism. That all changed 10 days later, where Mars 2020 was deeply questioned by what happened around. From within 2 weeks, basically, we went to a near total lockdown. We immediately made a decision in our team that we want to try very hard to keep Mars 2020 on track. And frankly, friends, the reason I was so passionate about it is not so much because of the $500 to $1 billion we're saving the taxpayers by keeping it on track, but I was actually even more motivated because of the fact that I knew pretty quickly as a scientist that we're going to be in for a long haul. And as a nation and as a world, we needed something to cheer for that is bigger than ourselves and talks about the spirit that we have to overcome this. And so basically, the next slide, we turned our entire team around. And of course, in the clean room, the people have to wear these masks anyway. We had to isolate the entire workforce from the environment. We actually created a whole airline for them using our research airplanes to keep them separated and totally isolated because we could not have any COVID impacts in that team. We shipped the spacecraft to Lockheed, where of course the rocket was also being built like this. We struggled mightily. We basically finally, the next slide, launched it 10 days into the launch window. This is much longer than we normally take. We want to go on day one. Generally speaking, it took us 10 days, in part because of COVID impacts, in part because of technical issues. In fact, there was a day, something like a week before launch, where we knew that we had a problem on top of the rocket that we needed the one welder to fix. And if it was not diagnosed the right way, we're not going to launch. It was really close. Nonetheless, the spacecraft took off into the sky with the largest audience we've ever seen watching it. Some of them in remote schools, some of them from their homes. I don't know what you were doing when we were up there, but we were up there and really going into the sky. Now, what's interesting, whenever you go to Mars, the launch is never the easy part. Usually the launch is the risky thing, but the launch here is not the risky thing. The risky thing, of course, is landing 7 months later. And so there we were, next slide, getting ready to land. I was actually at JPL, and you see me there in a suit, slightly overdressed, next to Lori again. And frankly, I had walked across the field, and I met this team. This is what is the entry, descent, and landing team. So those are the people that day that made sure that the spacecraft was in order and ready to go. This is, by the way, the first time they met each other in person since COVID. For nearly a year, they had not met each other in person. They had prepared the whole landing remotely with very few people there. Every one of us had 2 COVID tests, including myself, in the recent past, before that picture was taken. And we were there. And basically, this was literally a couple hours before what happened, of course, on this day in February as we were trying to land. On his knee, by the way, right next to Lori, if you look over the right, kind of as you look at Lori, kind of to the right, with his tan pants is the lead of that team, so they're out there celebrating, and we were all kind of eating peanuts out there, socially distanced, which is what the people at JPL do to give good luck. I'm sure it works. I don't know, but there we go. So the next slide shows you, of course, a moment that we were there. Everybody now knows Swati Mohan, who is the number 2. See, next to her is the lead with that plexiglass. That's the guy you saw on his knee. Swati was the voice during that whole thing. A voice that I'm going to play for you in just a minute. Now, what I want you to remember is what's happening, of course, is after 7 months of travel and kind of really mapping the spacecraft against frankly, against radio sources in the sky, and really measuring also the Doppler shift of the signals, we basically know where we're coming down, and we have a trajectory. It's basically now, after a certain time, 2 hours, just after these guys come in, it's all load and go. Light is far too slow for us to affect anything possibly. It just has to work. And so what happens, of course, is we're coming in. We use the shell kind of to fraction of the shell to slow us down. It's the atmosphere of Mars is only 1% of the Earth, so it's not enough to really slow us down enough. So we put out supersonic parachutes. And then as we're hanging from the parachutes, we're actually using a camera. And we're trying to find out where we are and identify, based on pattern matching from space images that we had taken with another spacecraft, identifying where we are. And we're actually then dropping off the parachutes, and we're using a sky crane. You've seen the movie. It's basically a spacecraft that is flying on boosters, and there's wires coming down that the rover is being placed. Now, I just want you to know where we landed. We needed software to work that actually flew us away from big rocks. So if we didn't have that software, the likelihood of failure just from rocks alone, statistically, was 20%. Now, this is a $3 billion investment of the American taxpayer. 20% failure rate is too big for that. And so we had to actually test, and we did with helicopters in the Nevada desert, that this software worked. And I'm going to show you some of this before I show Andrew Holt still. What I'm going to show you is actual footage. We had actually, in this case, brought cameras with us that looked both down from the bottom of the rover, but also up from the rover to the sky crane that held it, and down from the sky crane down to the rover. And so you're going to see all of these movies at once. So go ahead, Andrew, and play it. So we're just off the parachute here, and we're on the sky crane, basically flying around. The sky crane is locking into the landing site and is identifying us. And so basically what happens now, this is actual footage, not some artistic thing. You see the boosters at the bottom kind of kicking off dust. You see the sky crane making the movie at the bottom, the rover making the movie of the sky crane letting it down. And you see a big mess there as I'm in the middle of a dust cloud setting down. And then you see the sky crane flying away. And of course, Swati, you didn't hear it here, was announcing to the whole room that they erupted, that the touchdown is confirmed as they went down and cheered. I was in the back of that room. Needless to say, we're really excited about it, especially because of the fact that I knew that before actually the sky crane had found the lock, we had an error message that was sent to us. That's something the sky crane identified a power problem, which did not turn out to be important, it turns out, and I'm really glad. But that is what perseverance means. Despite all the obstacles, despite all the complexities, despite not being together, remember again, they're for the first time together in that room. They basically achieved what is a tremendously historic landing of the type that nobody had ever achieved before. It's the 9th landing of the United States, the 9th successful landing, and of course the most complex one in terms of its accuracy needed and technology that enabled it. The next slide shows you a selfie that once we were up there with the arm, we're taking it, and you see there's another kind of robot that's there, which is Ingenuity that we had dropped off at that point. And we're, you see the cameras moving around to kind of just to kind of get your attention. You saw, of course, the wheels that dropped the helicopter off. This was a technology demonstration done with a fixed budget. So basically to try to achieve for the first time autonomous flight, the controlled flight in another world. So that's what we did. And the next slide shows you one of those flights. You see at the bottom left there, the helicopter spinning up. What you're seeing is what the rover saw. The camera that was turning its head saw that. And basically what you see is the helicopter going up in front of that ridge, and it's turning to the right and is flying out of it. By the way, remember when you see that thing flying, that it's doing so in 1% of atmospheric pressure. That's much higher than Mount Everest. It's close to 100,000 feet high in terms of the overall height in the atmosphere. So it kind of the vehicle in terms of its control, but also its spinning of the rotors, of course, is a very different vehicle to control than one that's there. In the meantime, of course, the Ingenuity had flown quite a bit to the right, and it's coming back, and it's going to go land back down. So it landed back down. The first 6 flights, by the way, we always landed where we took off. And what happened on the 4th of July, to celebrate our nation's anniversary, our nation's birthday, that is, what we did is we achieved a record-setting flight where we were flying straight through and actually flew over a dune field that is not safe for the rover to go. So we actually took data that is otherwise unachievable. And Andrew, if you don't mind showing it, what you see is the camera looking down. You're seeing its own shadow. It's around noon on Mars time, and we're flying across this. You see it's a little bit choppy, of course, because of the internet. It's over 600 meters of flight directly, a straight shot across. And frankly, when we started flying this thing, we thought that 600 meters would truly be a suicide flight. But no, it's doing well, and it's doing this in service of science. We went from tech demo to this helicopter working for the scientists, and they're basically using it to make the missions successful. The mission successful, of course, of the rover, which is Perseverance. The next slide. Which of course is the first leg of our first round trip to Mars. We of course have a history of rovers that are there. What we're working on right now is a lander on Mars that will be there in the late 20s. That will land the first launch vehicle and will, of course, bring with it into orbit around Mars, bring with it the samples that Perseverance is now collecting. We're, of course, interested in the science of this, especially as we're in this dried out lake bed, which is Jezero Crater. But we're also excited because of the fact that as we're doing the first round trip to Mars, we're getting close enough, within striking distance. There's still a lot of things to invent, but close enough to having a discussion what it would take to making, that movie, The Martian, making that a reality. So basically, every once in a while, recently I met this child and he said, "Did you see the movie The Martian? You remember that launch vehicle there on the surface? We're building that right now." So that's what we're doing right now. And it's just the next step in a proud history at Mars, again, enabled by amazing teams that persevere. So as we go forward, Andrew, I just want to remind you, of course, that as we, in fact, come up with these vision, equip ourselves, build the right teams, and then persevere, of course, that gives us the courage to do things and do missions and achieve challenges that we never thought possible. Andrew, just turn on some of these slides. By the way, I don't really want to talk about the slides. I just want to show you some of the results, some of the data of our missions, whether it's looking at our amazing sky, whether it's looking at the sun, at other planets, and kind of teaching us about nature. As I said before, just looking at the sky, we always realize that this is important, and therefore I'm deeply resonating with the mission that you have as astronomer, in your Lowbrow astronomy club there, really focused on observing the sky together from the ground as we seek to do the same and enrich the same from space, both looking up, looking down, and looking at other worlds. The sky is much more interesting than when I studied astronomy and physics today, and it's much more worth looking at this. This, by the way, is Jezero Crater, where we just landed. With that, what I'd like to do, Andrew, is have you go to the final slide and then take down the slide deck and see whether there's any questions I can answer. Thanks, everybody. Over to you.
Thank you, Thomas. Great presentation. Questions?
Getting to Ingenuity, I noticed that it has two lift motors, but I didn't see any other control surfaces or side motors. How does it move laterally?
So what we're doing is we have two counter-rotating, so we have four rotors, so to say, counter-rotating to each other. Do you know what I mean? And so the way we're moving laterally is we can pitch each one of them against each other. So what we're doing is like as we go around, we control each one of the surfaces. And so by breaking symmetry, you can, of course, create overload on one side and it's moving. So that's how it's done. By the way, that took us a while to figure that one out. Just so you know, it's an unobvious thing, and everything has to be done for very, very low weight. So we actually were like cutting off like heads of screws to make sure that we fit into the weight limits. So it's the whole thing is 4 pounds end to end. But thanks for the question.
Thank you.
So I see Barry has his hand raised. I think Barry Wisman. Go ahead.
Come on, I know we got more questions. Somebody?
Yeah, are you going to be involved also with the Europa Clipper?
Oh yeah, I spent 3 hours this week on the Europa Clipper. Yeah, that's also in my program. So let me just tell you where we are there. So actually, we're getting to the integration now of the spacecraft. So we basically, frankly, 2 weeks ago, I went and looked at the whole propulsion module that's in DC right now and basically being fully assembled and the harness, all the instruments, the first instruments are coming in later this year. And basically the systems are being developed, coming together. We're in the middle of a launch vehicle competition. The launch is anticipated in mid to late 24. That's what we're heading for, and we're doing well on track with that. So it's going well. It's a really complex mission. The instruments there are just incredibly sophisticated, and of course, what makes it so hard is the horrible radiation environment that Jupiter provides. With its radiation belts, right on top of Europa. It's like the worst of all cases. It's cold and super radiation, like, ionizing radiation, but it's going really well.
Following up on that, are there plans or any progress on a mission to Europa that would actually melt through the ice and take a look at the water?
So the answer is there's many ideas of that, right? And we actually have a technology development program going to learn how to land on Europa. But I want you to know, so there's many responsibilities I have. Let me tell you about a responsibility I do not have. And that is, I'm not in charge of prioritizing science. So we're doing that in the United States through the national academies. So we're asking the scientists to do that. And frankly, next year, I should hear back from what the priorities should be in the next 10 years. I would not be surprised if one of those missions are prioritized. At this moment in time, it's not the priority. The priorities I'm working on were Mars sample return and the Europa Clipper. I'll just tell you, it was called differently, but it was the Europa Clipper. Those are the big priorities. Of course, what I've done with non-strategic assets, I put an emphasis on Venus. Recently, we have what I would call 2.5 Venus missions. I basically felt that it was really important. Well, so I look at each one of the missions individually as a selection official. I mean, actually did not come in and basically say, hey, it needs to be Venus. That would not be fair. What I really look at is kind of the how the missions are, but also look at how it fits in the portfolio. But I'm really excited that we ended up with 2 Venus missions in the following sense, one of them being the best mapper, up to 2 orders of magnitude higher resolution in many ways than ever mapped, going right through the clouds. And then one is a probe that goes down to the surface. The Europeans also selected a Venus mission, and we're building one of the top instruments there also. It's a slightly different, or together, they're really a big campaign to Venus. So that's so Venus is fashionable. Of course, the reason for that is in many ways because of astronomy, actually. So it's interesting because it's a terrestrial planet and we don't know enough about it. But I just want to tell you, there's so many Venuses we're observing in our own galaxy, and we need to understand our own. We just really do not at this moment in time understand our own Venus, so we need to do that. So those are where the priorities are. Of course, besides some of the lunar and other things. But that's where we're going.
I have a question. Do you work with some of the contractor groups like SWRI and JPL in running these missions?
Absolutely. So go ahead.
I was going to say, what's your role in regards to those and coordinating that?
So basically, if you want, I'm the top guy in all of the science programs, right? So I'm basically, if you go from the top of the agency, there's the administrator, his deputy, there's a chief operating officer, and if you look at science, then it's me. So I'm in charge of all the missions and the whole distribution of money. So some of the money goes to Southwest Research Institute, like you said. Some of it goes to APL, some of it goes to JPL, some of it goes to Goddard, some of it to Lockheed Martin. And so basically, I'm running the organization together with my able team, of course, to basically build the processes and systems that actually select the missions and kind of compete them and then keep them on track, right? I'm the person who defends them to Congress. So that's how we relate to each other. So I used to do work at Michigan. I built some instruments there. I was involved in missions, various missions, but I don't really do missions now. So I'm not standing in a lab with a screwdriver anymore or with a vacuum chamber. I'm really, what I'm doing is really kind of the top level leadership, and strategic guidance. Does that make sense?
Yes, thank you.
Yeah, Barry?
Very good.
Dr. Zurbuchen, I was just wondering, in your tenure at NASA, what you felt was the most sort of outstanding or unexpected result you've achieved, and what result you're most looking forward to?
God, that's actually a really hard question to answer. But let me answer just on the programmatic side first. I think getting Mars 2020 off on time and landing it successfully was almost impossible. And, we really struggled when I came into NASA. I would have said that the likelihood of launching in Mars 2020 in 2020 was around 50% because we had so many challenges and I was basically part of a turnaround. We only had one, so we're looking every month at our color scale. We were only 1 month, we were green on schedule, which was February of 2020. So we had caught up, and that's the only reason we launched, right? So we basically backed out of the corners we were in, we built a team, and then we were ready. We were an incredible team and, helped each other. I had to solve problems I've never solved, right? Kind of nobody has ever solved, right, during this COVID, and so did the others. So to me, that's one of the biggest achievements. If you ask me for what's the number 2, I would have said it's building a team we have right now. I just want to tell you, I think we have incredibly strong team, there's many people are there, like many of them, we had to fix some things, including the leadership of James Webb. Greg Robinson, if you have a chance, that's the kind of guy you want to talk to. He's running Webb right now, right? He's just an incredible guy, and I brought in, right, into that position. So that would be the number 2, just a team. What am I most excited about? It is Webb launching and deploying, right? It's truly historic. Nobody has ever seen anything like this. It's looking at the universe in a very different way, and I'm scared enormously, right? It's somebody who's not worried about it is not realistic. Now, make no mistake, we're doing exactly everything we should. Just, by the way, I was equally scared landing on Mars because a single mistake can take you out. So I'll tell you, James Webb has over 300 single point failures. Anything of these 300 things do not work exactly like they should, we're not going to deploy. And it's a wasted $10 billion. So for me, of course I'm scared, but I'm proud of the team. I just met the team. That team is it's a cohesive team. I could not be more excited. I think if you ask me what's the number 2, I would have said Mars sample return. It's just, it's another just leap. We've never done a round trip to another planet. And, for me, learning to do that, for us as a team, learning to do that is just absolutely important, right? It's kind of, we need to do that. And it's really, really incredible. So that's how I would answer, Henry.
Somebody recently told me that if you want to get somewhere you've never been, you can't be afraid to do something you've never done.
Yep, exactly right. And I tell that to myself many days, but for me, look, the way I think about this, I'm actually a big champion of actually talking about what worries us. I remember the first I joined NASA, and I of course have this PR department, right, that is protecting me from making a fool out of myself, in principally, but also helping me with all the different things that I'm supposed to do. And I got a question with like all the journalists, are you worried? I said, absolutely am I worried. The PR guy almost fell off his chair. It's like, you're not supposed to. We're confident. That's the right answer. It's like, well, I'm confident, but I'm still worried. I'm still worried. And frankly, I want us to tell people when we worry, because that makes us human, first of all. We don't walk on water. I think we should not give the impression that we're on top of things, but we're not walking on water. We're just humans, just trying to do our best. And of course we're worried, but we struggle together, and the teams give us the chance of, even though we may make mistakes, catching those mistakes and being perfect as a team. That's what it takes to land on Mars. That's what it takes to do Webb. And that's what we need to learn to build a team.
You might not walk on water, but you're following the water.
Yeah, that's right. We're following the water, and we observe water on Earth, right? We're doing amazing stuff, but also there, it's just as hard. I could take any of my missions and tell you any one of those stories, and I hope I get a chance some other time, with some of the Earth science missions that are in every way as complex. But get you.
Doctor, when you
we'd love to have you back for a part 2. Sorry, Norm, go ahead.
I was going to say, when you speak of James Webb, I'm thinking of the famous Hollywood line, failure is not an option. But with all the headlines of all the rockets and stuff going up with the billionaires, how is SLS going in your frank opinion?
Well, I think they're actually closing in on a success. I mean, so first of all, they have an amazing leader now. Kathy Luters is just a superstar. In many ways, we're actually very similar, very direct, to the point, people focused, and that's what it took. And also kind of say, we don't accept certain behaviors, right? So, and I think we're stacking the rocket right now. We're basically every test that we've done with every one of the propulsion systems has worked. The full integration, we have a really good team on it. And I think there's a very, very good chance this will work exactly the way it should. I mean, frankly, I think just the same way as Webb, right? I think this looks really good now. It took us a long way to get there, right? It's just, I mean, it's way too long. And everybody accepts that. And then, by the way, I'm saying in the same breath, same for Webb, right? I'm not, he was without sin, throw the first rock, right? I'm not going to do that, right? Kind of my point is, I recognize it took too long. And kind of there's a long discussion behind it, why. And frankly, I don't understand SLS. My job is to understand why we got ourselves into trouble so much with Webb and never doing it again. That's what my job is. So.
Okay.
Well, it's like a sign I saw in a non-fast food restaurant one time. It said, "Good food cannot be made in a hurry."
Yeah. If that was the only reason, it's true, but we made some horrific mistakes. I have to tell you, when I figured out when we did the first acoustic test that bolts were flying off it because we hadn't locked them, that is absolutely unexcusable under any circumstance. If somebody did that at the University of Michigan in my lab, I would kick them out of the lab. That's exactly how I feel. I mean, you cannot be sloppy. And you can talk about this all day long, how that happened. It's like, basically, when I figured that out, it's like, we do not have a winning team. If the people who touch that $10 billion expensive hardware do not have the same urge to be successful as I do, I'm going to fail. We're all going to fail together. So we had to reboot the whole team, basically everybody from top to bottom, and of course, it's middle management usually and top management where the problems are. We shouldn't go after the technician. Usually the technicians, they're telling people, this is stupid. Do you really want me to do this? And, the top guy says, hurry up instead of listening, right? That's usually what happens, right? So, I mean, by the way, that's what happened in my lab, right? So there's nothing that makes you more humble than kind of building actual hardware and learning that yourself. And so for me, that needed to be learned in this mission. So I understand there's certain things that just take longer because they're complex, but I also don't want to hide. And you'll never see me hide, whether it's with a congressional committee or here or with our own team, things that should not happen. There are certain things that we need to do better of. We need to catch each other's mistakes. It is not acceptable that we do what we're doing. By the way, this was a team for 2 years. They made a 6 months mistake every 6 months. So in other words, they were standing still for 2 years, just screwing up, right? Kind of not making progress. And I rebooted the team, and I want to tell you, they stuck to it, and they've not made any mistakes since then of that type. You can turn around a team. That's whether it's college athletics or, whether it's a company, or whether it's a James Webb, you can turn around a team because you have good in your team. You just need to amplify it and kind of wipe out what's not good, right? So I just want to own that, right?
What's the next dramatic step then that we'll see in the SLS coming up? Because it's sort of been on the back burner in the off the public radar, I'd say.
Yep. So it's launched later this year. That's the next step. We're going to roll. I mean, we're assembling it right now.
Okay.
And it's later this year, and it's I don't know. I'm not trying to hide it from you. I just don't know.
No.
It's not my
No,
responsibility.
we'll hold you to that, though. We'll hold you to that.
Yeah, I mean, that's what my full expectation is. As of last week, I talked to the director. I mean, my colleague, the
Right.
associate administrator. That's what we're expecting.
No, that's great news. Thank you very much.
Is there going to be a payload for that, or is that just going to be a dummy weight?
No, the Orion capsule is going up with it. So it's kind of a joint collaboration with the Europeans. It's also basically a capsule that really is kind of a pathfinder, if you want, or for what will be the gateway, which is basically in orbit around the moon and becomes a way station to the moon. So, and there's a bunch of kind of small satellites and kind of drone, like little things that will fly with it as tech demos. I don't really have on this one from the science directorate, I don't have any payloads on it.
Okay.
Well, how do you think, Adrian? You want to get going with your director's meeting?
Well,
I think he's muted. I don't know whom to ask. Charlie, is it you? I should ask.
I thought somebody asked a question.
Oh, okay. Go ahead.
Well, it wasn't me. I thought I heard somebody else ask one.
There. Now you can probably hear me because I didn't have my mic in my mouth. No, I was just another Bravo giving us some insight into how things go with NASA, and also it warms my heart to hear the way that you all as a team work, because it's something that I would love to have in the industry that I work in, which is I work for a bank in IT, and the problem solving and the teamwork is just something that's a challenge at that level. Speed overcomes the need to make sure we get it right, and so we struggle with that. So if you're taking applications, just let me know. And with that, I'm going to go back on mute and let Charlie have the last words before we move on to our officers' meeting.
Yes, and one more thing to cover with you, Thomas, is we'd like to give a little gift just as a kind of humble token of our appreciation to our guest speakers. And that would be a club t-shirt, which looks like this. And then we also have some baseball style hats of a couple different varieties. Do you have a preference?
Oh, I'll take a t-shirt if you don't mind. And frankly, I can, we're dropping off a daughter later this summer. She's coming to Michigan. I figured out how to take a job that pays half as much and to pay out of state tuition for the school where I used to work. So that's what I'm doing. But anyway, my point is we're going to be in Michigan, Charlie, if you want to save the sending it out, but an X large t-shirt, that's what my size is in case you want
extra large. Yeah. Okay. Well, I mean, when are you going to be around? We have no problem shipping it to you. That's not that much.
I think it's going to be, when do they usually start? September, right? Beginning of September.
Yeah. Classes usually start beginning of September.
Yeah. So that's kind of just before that. And we can stay in touch. My team knows. And we can do it will be easy, right? It's by the way, I'm not 100% sure I'm going to be there because I think we're launching a bunch of stuff, and I'm going to be in anyway more than you want to know. But anyway,
stay in contact with me. It'd be my honor to personally deliver that to you.
That's really nice. Thanks again for spending time with me tonight, and really appreciate that. Hey, Andrew, really appreciate you spending time with us tonight.
Yes, thank you, Andrew.
Yeah,
we're really privileged to have you. Thank you very much.
Appreciate it. Thanks so much.
Thank you.
Thanks. Okay. So with that, we'll move into officers' reports. The only thing I have is just to mention, as many of you probably already know, the longtime manager of the U of M exhibit museum planetarium, Matt Linke, has actually retired after, I believe it's 31 or 32 years of service there. And we've had a little bit of exchange of, congratulations, thank you very much, hope we still see you around kind of emails. And then Jack Brisbane came up with the excellent idea of making Matt Linke an honorary Lowbrow member. The officers that responded to that, of course, were all positive. So I reached out to Matt and asked him if that's something he'd be interested in. And boy, was he honored about that. He was more happy about it than we were. So anyway, Matt is officially now an honorary member of the Lowbrows. And he has assured me that we have not by any means seen the last of him, that he will be showing up at events of different types now and then, particularly and especially if we go out again to Hidden Lake Gardens, which I expect we will, because he actually lives not that far from there down in Tecumseh. So in fact, him and his wife are members of Hidden Lake Gardens. So anyway, Matt Linke is our latest honorary member, and we will be seeing him in the future, which pleases me very much. So with that, I will go to other officers.
Charlie, can I interject a question, if I may?
Yes, go ahead.
Both his position at the planetarium and that astronomer position at the Detroit Observatory, have those been filled? Have you heard? I haven't heard anything about that.
I know they were looking. I have not heard an update from Gary Krenz on the Detroit Observatory.
Okay.
And I think Matt may have told me that they did select a new manager, but don't quote me on that. I have to go back and look at the email again. So, but I think he said maybe they did or they were about to. But he did also say that's another thing he wanted to do is get us in contact with that person so we can establish a relationship there. Since we've always had a relationship, he would like to see that continue with the new manager. So he's going to see what he can do to establish that as well.
Okay, it's good to hear. And I didn't hear anything if the Detroit Observatory construction project is on track or how that's going. I haven't heard much over that way.
I haven't heard an update just recently either. So
yeah. Okay. Thank you.
All right. Yeah. Thanks. Okay. Joy, thank you for doing the minutes. Do you have anything to report?
Just still waiting to hear any info about whether or not I can change events on the calendars for when we might be real meetings live.
Yeah, it'd be nice to fill in some actual times and dates, wouldn't it? Well, we're getting closer. So, okay. I did see Liz, but I think she left the meeting. Liz, oh, there you are, Liz.
Here's my report.
I need to pick up the keys.
I still have them in case you want to go out of town again, Jim. No problem. I hope your basement is dry, given all this rain we've had twice now in about 3 weeks.
So far, so good.
So that is my report. I am standing by with the keys. And, waiting for the skies to clear as we all are.
If it doesn't stop raining pretty soon, you're going to hope those are keys for a boat. Okay. Dave Jorgensen.
Yeah, I really don't have anything to report, Charlie.
That was quick. Thank you, Dave. How about you, Adrian?
There's a lot going on. Still doing the Explore Scientific nights, using that for outreach. Stuff with the WUS has picked up. The WUS is going forward with their picnic. And the Astronomy at the Beach voted to have an event, an outdoor event, masked and social distance, no speakers. It's just going to be a basic star party. So we are taking the chance of seeing if the public will behave and how we're going to share scopes and eyepieces. And we're not sure what's going to happen, how the future is going to look in September, but I think all hopes are that numbers continue to go down. So far that's where we're at, and we'll modify things if we see a reason otherwise. But that was the final vote for astronomy at the beach. So September 24th and 25th are when it's going to go down. It may well be one of the first to the public astronomy events that has been held since the COVID-19 pandemic's been going, and so it's going to have some eyes on it. And if not, we'll continue to work through it, um, and we'll see how that goes. In other news, the Astronomy League or Astronomical League online convention is coming up in 2 weeks, and it's free. It's online. David Levy's one of the guest speakers, and feel free to sign up and join. I think you can go to alconvirtual.org. I'll type something in the chat with the location for or the online location if you want to attend the Astronomical League conference. And that's all I can think of. Just sort of staying busy and driving here and there. The smoke's kind of slowed me down a bit, but if it gets clear again, I'll be back out. That's it.
Back up some mileage, Adrian.
Yeah.
Adrian, Adrian's the president of GLAC. I'm vice president. I just would like to add that this is a bit. We're being a bit adventurous by having an in-person event, but that's really our purpose, and we're very serious about the masking, especially with respect to children under the age of 12 who can't be vaccinated. Now, we are going to need people and telescopes who are willing to participate in that environment, and we need, prompt feedback about that. Who wants to be out there? Who wants to share their telescope views with the public, given those parameters for those protocols for behavior? It really, our success and the success of the public with our event depends upon the participation of the people in the clubs. So if people can respond to us and tell us whether or not they are willing to come out and do that with us, that's very important.
I have a comment with regard to the Wesleyan Observatory over in Fremont. They're going to have a public session here within the next week or so, and so it'll be an interesting experiment to see what their cooperation is, to see how that goes. So I was going to ask them about how that's all going to go over.
Yeah, Norb, please do, and keep in touch, especially with me. Shoot me an email, because I'd be interested. I don't know what kind of time I'll have, but if I could go observe what they're doing, that would be a good way to see how this is going to work, what it's going to look like. I'm curious.
Well, I was going to say I can put you in touch with the people that I know over there. It's a good group, and they get a fairly good turnout over there. So
please do.
They're digging in and going to commit to a public session.
All right, well, please do. Yeah, I'll talk to them because I'm very interested in how they're how they're handling it. So, all right,
okay,
I'll send you an email.
Thank you.
Based on what I heard John say, I'm maybe getting the impression you didn't get a lot of results from this AATB survey that was sent out.
We did get some results. I know Brian isn't here, but the results were basically of the public that responded. They all wanted an in-person or hybrid event. If it was fully online like last year, they were less likely to come. Of the astronomers that volunteered, it was all over the map, but there were astronomers that said they would volunteer their scope if we had an in-person event. So it's all over the map. It's the general public was stronger in favor of being in person. The astronomers were more cautious about it, more aware of possibility of spread. But if if there was an online event, they would volunteer. So we decided we were going to do a hybrid event, and then Brian reminded us that we didn't have the resources to do both, and said we just need to focus on one or the other. So when we put the vote to the table, the online event at the park won. So for now, that is the plan: is to do the simple event, bring a telescope, socially distance your telescope. We know the chaos that it could cause. There will be those that have that will refuse to come out and have every right to do so. There's there's a chance for some spreading, especially if things get worse. We don't know yet where we're going to be with COVID. We're pretty sure COVID's not going to be done. There's also going to be those that are going to be happy to come out, but they'll grumble about the masking and social distancing that we require, especially if they're vaccinated, or they'll grumble because they've done it the entire pandemic. But at this time, we figure we need to make this as safe as possible, and having those masks with you and putting them on is one of the safest ways to do that, is proven by those that didn't catch COVID during the pandemic and utilize masking and social distancing. So that's where we are with it. And this event that Norb's talking about, I'm curious to see how they're going to do it. So I'm planning on trying to get there. Jim,
Adrian,
go ahead.
if you're requiring masks, you're gonna have to provide them.
We will. We will.
Okay.
We will. We will. We haven't discussed that. I'll take that upon myself. We will have masks available for all comers, and we will try to. The Department of Natural Resources, the parks, have been cooperative in this. Our charter is to put on the astronomy at the beach, not to have an online event, and we want to keep our wheels on the ground as successfully as possible. I believe that we can do this successfully, and I believe that the public who shows up for those events will be cooperative.
Okay. I see the Great Lakes Stargaze is going to meet, of course, but they're not going to have the gathering tent or a public, or guest speakers or any of those kind of gathering events. That it'll just strictly be astronomers showing up with their scopes and observing.
Right, they did that last year, and it appears they were successful. Difference between that and our event, though, more serious astronomers able to, the social distance thing, much easier to do when it's a serious event. You're there to observe, you're not there to run around and, shine your cell phones everywhere. It's not the same type of public event that we're putting on for astronomy at the beach. So
right,
there's more risk with astronomy at the beach. The general public, it's a crapshoot. We don't know what we're going to get, but we're still looking to put the event on. So that's where we are.
Thanks, Adrian. Moving on, Jack.
Okay. We'll start off with our observatory. And I'm right now sitting
prepare everybody.
chair.
This is going to disgust you.
Now, if we got, okay, everybody should be able to see this. We got this out right. Ta-da. Okay, we're going to go this way. All right. Everybody hear me okay?
Yep, and we see the thumb in the picture good too.
Okay, here's what we're going to do. First off, here's the observatory as it looks. We finished it off. And you see all these tall trees in the background here. As you know, there's a tree maintenance group, and we're working on removing the trees that are probably within, we'll say, 60 to 80 feet from the observatory. These trees are, some of these are as high as 70 feet or more taller. So that's what we're working on right now. A little bit on hold because of all the rain. It rained all this week. We usually have been going out once a week, to start on this project this week. Did not happen. And if it is as clear, not clear, but as sunny and partially cloudy every day like they claim next week, then we'll probably have at least one meeting. I don't know, maybe two, depending on weather. I don't know. And then we'll continue it from there. Now, for those of you that have wondered what we've been kind of talking about here, we had an incident that happened sometime between July 7th to July 15th. Thursday, after I was done working on the 17 and a half inch, we're cleaning the mirror net over at Dave Jorgensen's house, myself and Jim Forster and Dave Jorgensen. I decided to stop by the observatory, just take a look, see how things were going. I often do that when I'm out in Ann Arbor sometimes. And me and Jim Forster went in there. And as I drove up there, I noticed this on the wall, the graffiti. And as you know, this is constantly what goes on out at the Radio Observatory building. They've had a lot of different graffiti, stuff written on the walls. Here's the other side of the wall. This would be the south wall. I'm not sure the symbolizing of this graffiti, what the symbolizing means to some people or not. As you can see these little things here. And there's probably some meaning that I don't understand or know about.
The ghost looking thing is a game character, my daughter says.
Oh, which one now? This one, these two here?
No, the red thing. Yeah, that one. That's a game character.
Okay. Yes, very well could be. People like to do that stuff. I don't know what the species is, unless they were trying to tell us something. They're from another world. I doubt that.
I'd like to send him to another world.
Oh, yeah. But they're going to have to pay their own way. They're just going.
Yeah.
So here is another, probably, I don't know, some character for something.
I think it's the Among Us game. That's starting to make sense. That character, okay. I remember seeing Among Us, a video game. There were some guys that I knew that were playing it and streaming it, and that looks like some of those characters or maybe tags or handles from that game.
Okay.
Looks like Kathy just confirmed that.
Yeah.
Oh, did she? Okay.
Yeah.
Because I figure it's something like that, because it's not the same as the more, shall we say, obscene graffiti that you see on some of the walls in the past. So, and then we had just numbers, random numbers. This 117 and 69 were written up here. Like I say, this was reported. I did call up the U of M police and waited for them to show up out there. We had a little discussion about what's going on and everything. And the officer walked around the building, checked some things out. And there is an official complaint filed with the U of M's police department. And for right now, that's all that's being done. Now, I don't know what will happen into the future here if they ever find anybody. But eventually, right now, this coming week, I'm going to be trying to work on getting more of this tree work taken care of and that. But plan on going out there and just testing some of this paint, see if I can dull or remove it with something liquid. The paint we painted the building with, that particular paint, it's a heavy and thick paint. It's what they call it's an elastic paint that stretches. And I'm thinking that we could just maybe chemically reduce some of the deep coloring and just recoat it with the white paint again. I don't know if that don't work. Then we'll have to primer it and then paint it. But that white paint is thick and it is heavy, so it might just cover it all right without too much of a problem.
Jack, a suggestion here, removing the graffiti just makes another surface for more graffiti. I really and I may be odd here, but I don't see any problem with just leaving it because our events that are at nighttime will, the darkness will not draw attention to it. And I don't see anything there that is, particularly objectionable that, in my understanding. Maybe we just want to leave it alone and see what happens.
Well, the only risk in that is that it then begins to grow because they begin to add to the graffiti. That's how you end up with a completely covered wall. Now, all of it may just be more Among Us characters or, building upon the art. It's a no-win situation. If you clean it up, then like you said, John, they'll just rewrite it. They'll just write into it again. If you leave it there, then you get more graffiti, and then the entire building gets tagged. Um, so it's almost like the only way to really stop it is to by chance catch them in the act, and and let them know with no uncertain terms, don't come back. So yeah, it's a tricky one.
I know. I was thinking a little bit about leaving it up for the first public open house and just explaining to people, if you know who's doing this, ask them to stop. I'm not sure that would work neither, but it would maybe get the word out there. At least people would be concerned and think, yeah, it'd be nice if they would stop. But I don't know. It's one way of thinking of it.
I was wondering if you could use one of those cameras they use for wildlife, stick it someplace, maybe motion detector will, catch them in the act that way.
Yeah, I've looked at some of those, but we're going to have to get one that has a high storage value on it. The reason I'm saying that is Wi-Fi connections still don't really work out there. The only connection that they have established out there is by the radio observatory. There's a smaller building, and they put a Starlink in there. And I talked to Professor Cutler about it. He said they could pick up the Starlink from his building there, but when he went downhill by our building, they lost some of the signal. And as some as you know, last year, I went out to the building during one of our Zoom meetings, and I tried to pick up the signaling, and I got a lot of bandwidth interference, as they call it, some other things that you would miss the voice and some of the video events and things like that. So yeah, because we've talked about different types of cameras out there, but we can't rely on an internet to hook up and monitor the system. We could download the images, or at least have some kind of daily contact with them. The trail cameras are nice and they work very well. And some of them are on an internet system and some of them aren't, where they're monitored like daily or weekly, and they pull the, what do you call, a little card from their SIM card, I think it is, or something. So
well, how about a couple of fake cameras mounted in plain sight on the building?
Well, we could do something like that, or mounted around the building somewhere. I don't know if they would they'd have to be fairly high off the ground, or
they'll just steal them.
No, they would just spray paint them. That's what would happen to them.
Well, here, how about asking perhaps the art department to actually put a mural on the building, because there's nothing more inviting for graffiti than a blank wall. So just have the whole thing painted in some type of thematic, system, and then it's done.
That is not an unusual request, because I've seen other buildings I've looked at where they've done murals on them. I really haven't seen anybody go up and graffiti over those murals.
Mm-hmm.
Done some of that downtown Detroit. I've been out of state, other places. I've seen buildings where they have, I don't know who commissioned it, but they commissioned to paint something of, I don't know, it might be an outdoorsy type thing, or
Aretha Franklin's down there.
Yeah.
Yeah, no one's I've got some pictures of some of the commissioned murals, and there's no extra graffiti on those. The
Yeah, I know.
the buildings that's got some of the graffiti, it was a building where they just kind of let it go. They said just let them tag it. It was they wanted folks to tag it, so they did.
Yeah.
Well, that was my son's
I think you should put the Milky Way on.
Good idea. Good idea.
That's what I'm thinking. M31 or something.
Well, I can
Good.
provide an image and have them screen print that or something.
Well, the idea would be to paint it on the wall.
Yeah.
So it'd be more or less like finding people that have the ability to know how to do that and could design and construct some type of wall mural out there. If you want to try to do that. We can think of things like that, some kind of outdoor mural, maybe an outdoor mural with some of the telescope people observing with stars and planets overhead or something, or clusters or something. I don't know. There's different ways you can look at it. You just have to sit down, think about it, and explore the possibilities. That's all I have to say about it for right now. We'll just keep monitoring it and see what happens. This wall and the other wall, the ones that had the main graffiti. So this one just had some odd numbers. That's easy to take care of. And I don't know, maybe leaving them on for a while, let the general public see it. Ask the general public, if you know who's doing it, please ask them to stop. I don't know. That's one way to start. I'm not thinking that's going to help a lot because the radio observatory had a lot of graffiti on their walls off and on. Every time they cleaned it, somebody would go back and spray it. Right now, the walls are clean though, but they do
Hey,
have
Jack,
more cameras out there too. They're doing a lot more work.
If you do have a public gathering, I suspect that maybe the perpetrators love to hear the reaction of people to their crime. So I wonder if they'll be among the group that shows up just to see how people react.
It would be at our open house, and I'm not sure even when that's going to happen. I mean, I know we've talked about September sometime, and if you just read some of you might have read the research that's been recently published, came out yesterday and today. They're experiencing outbreaks in certain states now with the newer variants on this COVID-19, and we're starting to question how well this response is going to be handled if people don't get vaccinated. And I'm not going to spend a 30-minute argument on vaccination. I'm vaccinated. Most people I know are. So if we get another increase where hospitals start to get more patients, then the state or U of M may say, hold it, we're going to have classroom, but these other activities, they may put a hold on for a couple more months. I don't know. But that's what you have to think about. Personally, I was looking at sometime around September, October, having open houses. So that's the best I could say for right now about that.
I wonder if whoever the perpetrators are use Twitter or Facebook. I guess what I'm thinking is that maybe we put a post on both of them saying that we have suspects to the crime, just to kind of plant something in their mind.
I don't have a Twitter or a Facebook account.
No, the club
so
does.
Somebody would, yeah, if the club would want to, I guess I could put the picture out there and ask them to stop.
I don't know that getting into a fight on social media with anybody's a good idea.
Especially not the gaming community. That's where they gain. You might end up with a whole bunch more people tagging that building if you do that.
Yeah.
Well, that's true. Once you publicize something, there are people that want to take advantage of it for whatever reason. So
I guess I'm just thinking about a problem I had a few years ago with yard signs, political yard signs that were being stolen. After the second one was taken, when I put the third one up, I put it was actually at that time, although I have a working one now, but at that time, a non-working webcam in my front window. looking right at it. And then I put a little sticker on the corner of the sign that said, "I hope you smiled for my camera." And you know what? That sign didn't disappear.
Yeah. Yeah.
And I figured if it did disappear, then they're going to read that little sticker and it's going to be working on their brain a little bit that, oh my God, did somebody get a picture of me?
Yeah. Well, I'm sure we can continue to have discussions about this.
Yeah.
Now, I did send, just to let everybody know, I did send a letter. I know I sent one to the officers, but as to the general membership, I did let college, John Keaty, College of Engineering, know about it, and Sushila Fernandez out at SEAS know about it. They got a letter this morning with some of the pictures and everything. We'll see what happens. You can go to U of M Police Department and look at confirmation numbers, and there's a number there for us. And we'll just see what they find or what happens. Who knows? Somewhere else you may find the same signs and the same type of graffiti, suggesting it's the same person. Maybe. So that's it. No.
Thank you, Jack.
Okay.
Okay, last but not least, Doug. Is Doug still there? Well, I see his name's there, but I see no video. Hello, Doug. Well, he's apparently having some connection issues, so I'm guessing that he'll email his report in. So with that, does anybody have anything else?
Charlie, that was an interesting guest speaker that you landed there. I was, were you planning that, or how'd that come about?
I think Dave Jorgensen got on that, didn't you, Dave? Or
Yeah, I've been after him for 2 or 3 years when he was still at U of M, and Dr. Zurbuchen had put me in contact with a number of speakers in the past, but he never could participate. And then I heard he went to Nassau, and or NASA, and so I said, well, I'll give it another try. And so anyway, this time it worked out pretty well.
Wow. Very good.
Yeah, nice work.
Doug is here again.
Looks like I'm back. I don't know what happened. But you can hear me now?
Yes.
Yes, we can, and we can see you too.
Well, that's too bad. So 169 memberships. That's a lot. I think that's our max, but keep in mind 8 of those are I call them missing in actions, where after the COVID thing, we decided to just carry people's memberships whether they reply or not. So that's 8 of those, and this does include the Matt Linky that was just added today. Treasury, we have $10,385.70. I did for our biggest expense the past month, $235 to the Astronomical League for our membership for 2021 through 2022. And we have 30 people that joined. I think that's also a high water mark. Joined or renewed. Other than that, expenses were just a typical newsletter, mail and print, and our monthly hotline. And I mailed a shirt to Ani, who was our June speaker. And the only other business that I took care of, Liz is the only one that would care about this, or any other former treasurer, I guess, filed our annual e-postcard to the federal government that basically says, we're still in business and we have receipts under $50,000. So that's taken care of. And that is my report.
Just to piggyback a little bit on the report, for those of you who are in the astronomy that renewed or joined the Astronomical League, that conference is from August 19th through the 21st, 2021. So I was saying a couple of weeks away, maybe 3 or 4 weeks away. Those are the dates of the conference if you are interested in attending online. I posted in the chat earlier the website if you're interested in registering, and I'll post it again right quick before we close.
How
Thanks.
about the AATB donation this year?
Yeah, we haven't talked about it.
I haven't asked any of the clubs for it, so that's actually a very good question. And I'm gonna make John Wallbank responsible for going in front of all you lowbrows. John Wallbank just got appointed for. We actually wanted John Wallbank to chase down donations anyways, and use some of his connections for that. And you know what, John? Let's talk. Let's have you get on donations and how much we want from each of the member clubs and elsewhere.
Yeah, we'll pursue that at our next board meeting. Right now, our expenses are zero because
True.
at our planned event in September, we're not going to purchase any tents. We're not going to have any speakers there in person. We're not even going to have concessions. We're being super cautious about all this. But
True.
we're going to look. Adrian and I are going to look at our treasury. We're just setting up some new systems there. And then, yeah, in future, it doesn't take long to contact the clubs and, talk to them about whatever kind of a donation is needed. Right now, what we need is people. We don't need money. We need people.
Very good point. But I don't know if I want to turn down money just yet. So we'll talk about it at our board meeting. Next board meeting is second Tuesday in August or second Thursday in August. And all of you are invited to attend and listen in and give, and we'll definitely listen to any input that you may have for GLAC. So once again, I've
Well,
jumped into something.
Our planetarium's income for the past year and a half has been zero. So for me to ask the upper echelon for any kind of contribution would probably be rejected soundly.
Met with a firm Matumbo wag.
Yes.
Adrian, could you send us a reminder about that meeting as we approach it?
I will do so.
Thank
Either
you.
I'll do it or I'll make Jeff Cupmanis do it.
Well, speaking of Jeff, we did have a communication committee meeting. I don't know if he published minutes of it or not, but the one thing I remember is, because I worked on it, was the recommendations for email and how to manipulate it so that you don't offend the entire club. We do have a working paper and a little demonstration that Jeff put together. So hopefully by the fall, we'll have something that the club can post.
Yeah, good point, Jim. We did meet. There were about 6 or 7 of us, and it was I think it was a pretty productive meeting.
Okay. Anybody have anything else?
One other thing, Don Foley and I are driving out to Rochester Hills tomorrow. If may remember, one of our members passed away late last year, Tom Reichel, and his brother is taking care of his estate. And we're meeting Bob Reichel out there tomorrow to go through Tom's equipment. And some of it is pretty spectacular. So we're, I'm haven't gone through all of this with Bob yet, but I think he's looking at a sale similar to what was done for John Cosland, and Don and I are going out there to catalog everything and make sure that the photos he sent us, give us all the information we need. Some of the things that he that Tom owned are things I'd never seen before, and things that I can't imagine that anybody would want them. And then I look online and see what the last pair of Maya Uchi, what were they? Binoculars, 7x50s, right? 7x50s. Well, they sold for a small fortune. And so there are a number of things like that hidden away in his, in his collection, including a couple of ethos eyepieces and several Naglers. So if any of those things interest you, I hope you've got deep pockets, because there's no way they're ever going to be cheap, but they might be a little less than what you pay on Astromart or Cloudy Nights.
Jim, John Warren and Jim Ehlers are going to be doing the same thing for the late Brian Tiffany, who had, as an optician or optical expert, had amassed a spectacular array of things, from eyepieces to major league telescopes. And they'll too probably be putting out info to the various clubs about selling off some of his stuff, which has taken quite a while to inventory. So you may be hearing from John Warren and Jim Ehlers, who you probably heard through the Great Lakes Stargaze and other astronomy events. But yeah, it seems like these kinds of estate sales are. I inherited a 10-inch Meade, which I'm now using up at Scherzer from yet another amateur astronomer that passed recently. So it's wow.
Yeah,
interesting.
Lots of equipment, but unfortunately, that also means that it will be cloudy from here until about September 25th, with all of this, as soon as the gear begins to exchange hands. But it sounds like some really good gear is going to be available, so it may just well be worth it.
Ton of binoculars. Couldn't believe how many binoculars.
Yeah, I saw some of that.
Yeah, there's a lot of binoculars.
Yeah, there's some Maya Uchi binoculars that, are just, I've looked through some of them and they're just fabulous instruments. So, get your credit line established and,
I'll ask for an increase. I don't know if they'll do it though.
Yeah.
I spent the last increase they gave me, and of course I'm saving for an important trip, so I'm not sure I'll be in the market just yet to add to what's coming.
I'm putting up a he shed, as it's apparently termed, for my astronomy equipment. So yeah, my pockets are a little shallow these days.
Yeah, but it's good to know. I mean, it's unfortunate at how this equipment comes about. I was lucky enough to be paying John Coslin while he was yet alive for the equipment that I have from him. But I can tell you, I don't know if any of you know what happened to the 24, and I know Mike Radwick was online tonight, but it turns out the Warren Astronomy Club president and her husband are the proud owners of the 24, and they have property up north that they've used to try and spot some pretty faint objects. So the Warren Astronomy Club is the new home, basically the new home for the 24. So it's still being used as often as they can get it out there. They can get up to their property and use it, and so they're keeping it in good shape. So it did go to some good hands.
Okay, unless anybody's got anything else, I will.
Yeah, I got something.
Oh, Don.
I've got what I thought you might be interested.
Well,
I
that's
had
cool.
my
New Horizons.
yeah, I downloaded the files from the NASA website and had my son 3D print it.
Oh, cool.
Oh, excellent.
So I've got a nice model of the New Horizons spacecraft that I'll talk more about in my December presentation.
Sweet.
Cool.
Okay, I would entertain a motion to adjourn.
Motion to adjourn.
All right, do I hear support?
Support.
Okay, very well. Have a nice evening, everybody.
Good night,
Good
people of
night.
Earth.